Hello, my dear students. Welcome to the subject of statistics for the class 12th English medium, part 2, chapter 5, that is differentiation, presented to you by Vitan sir. Today we will be solving some of the illustrations, miscellaneous illustrations based on the working rules which we have studied till now. Let us start with illustration 15. We have to obtain derivative of y when y is 1 plus 2 upon 3 plus 4 upon x with respect to x. Okay, so we have to obtain the derivative, but before that we have to simplify the y into our one of the working rules. You know, we can only use working rules when the question is in the format according to one of the four rules. Now this sum is not according to any of our rules, so let us simplify it so that we can find out which rule we can apply. First of all, write down the question as it is. Now as you can see, we will start with the last section, that is 4 upon x. Now it is 3 plus 4 upon x, so x will be taken as the LCM, and in the next step we will get 3x plus 4 divided by x. Now what we are going to do here is that we are going to change the side of x and take it into multiplication with 2. So it will become 1 plus 2x upon 3x plus 4. Next, this part will go here as an LCM. So that way 3x plus 4 into 1 will be 3x plus 4 plus 2x, and in the common division we will get 3x plus 4. So the final form of our question will be 5x plus 4 divided by 3x plus 4. Now as you can see, this is a division. So we are going to use our third working rule of division, where the numerator is taken as u and the denominator is taken as v. What we are going to do, we are going to find the separate differentiations for u and v. So first one is du upon dx, that will be 5 into 1, x becomes 1 plus 4 becomes 0. So 5 into 1 plus 0, that is 5. Similarly for dv upon dx, 3x plus 4 becomes just 3, as x becomes 1 and 4 is a constant, so becomes 0. Next we are going to put our equation here. Putting the values into the question, as first one is the v, so 3x plus 4 multiplied by du upon dx 5 minus u, that is 5x plus 4 multiplied by dv upon dx, that is 3, divided by v value whole square. Next we will multiply 3x plus 4 with 5, that is 15x plus 20 minus 3 into 5x, 15x, 3 into 4, 12. Division we are going to keep as it is. Now we will be opening the brackets here, 15x plus 20 minus 15x plus minus 12. Next 15x minus 15x will be cancelled, plus 20 minus 12 will be left with 8. So our final answer will be 8 upon 3x plus 4 the whole square. So this is how we are going to solve our sum. We will move forward to the next illustration once you have copied it down. Pause the video here if you have not copied it yet, and then we will move forward. Next illustration is illustration 16. Now this might seem a bit weird as it is a different illustration and we have two variables here, x and y. 2xy plus 3x plus y minus 4 is equal to 0. Now first of all, we have to convert it into our regular y variable. Okay, we know that y is a function of x. So at one side of the equation we just need y, and on the second side we need everything else. So first of all, we are going to write down as it is. In the next step, all those values which don't have y in them, that is 3x and minus 4, will be changed to the opposite side. So when 3x goes to the opposite side and 4 goes to the opposite side, their signs will be changed. So 3x will become negative 3x and negative 4 will become plus 4. I have kept 2xy and y on the same side because both of them have the y variable. Okay, so apart from y, everything will be changed to the opposite side because I want y at the same place. Now in the next step, I am going to take the y common. So remaining will be 2x plus 1. Now this 2x plus 1 will go to the opposite side in the division like this. So now this is the standard format which I usually use here. y is equal to negative 3x plus 4 divided by 2x plus 1. So this is the equation which I wanted. Now as you can see here, it follows the working rule of division. Once again, what I am going to do, I am going to assume u as negative 3x plus 4 and v as 2x plus 1. In the next step, I am going to differentiate u. So negative 3 into 1 plus 0 will be negative 3. Similarly, dv upon dx will be 2 into 1 plus 0 is equal to 2. So now I have to put it into my regular formula here. V into du upon dx minus u into dv upon dx divided by v square. So putting these values from these four values here into our equation, v is 2x plus 1, du upon dx is negative 3, u is negative 3x plus 4 into 2, and in the division v there is 2x plus 1 whole square. Next I am going to multiply negative 3 with the value here, so negative 6x minus 3, and 2 with negative 3x will be negative 6x, and 2 into 4 is 8. Okay, so next I will open the brackets, negative 6x minus 3, negative negative positive 6x, and negative positive negative 8. So positive 6x and negative 6x will be cancelled, negative 8 and negative 3 will make it negative 11, and the division will be as it is, that is 2x plus 1 the whole square. So this will be the answer. Copy it down in your notebooks, pause the video, and once you are done, move forward to the next illustration. Next illustration is illustration 17. Now this is a pretty straightforward sum, but at the end we have a division here. So 1, 2 and 3 will be addition, subtraction, first working rule, and last is a division, so we will follow the third working rule. So this is a question which combines the first and the third working rules. Now sometimes there will be questions which combine the other working rules like this. At that time you have to solve them separately first and then combine them in a single sum. First of all, I am going to write down the question as it is, and then I am going to apply dy upon dx. So d upon dx and the bracket the whole equation I have written it down. Now we know that differentiation for 2 is 0, for 3x it is just 3, and 4x square, so 2x will be brought into multiplication, 2 will be brought into multiplication. But this last one here, for that we need to do a separate calculation. So that calculation I am showing you guys here. This is a division formula, so d upon dx into 5 upon 6 minus 7x. So what we are going to do, the numerator, that is 5, will be u, the denominator, that is 6 minus 7x, will be v. The differentiation for the derivative of 5 is 0, and derivative for 6 minus 7x is 0 minus 7 into 1, that is negative 7. So when we put 1, 2, 3 and 4 values into our division working rule, you should remember the formula by now. Okay, it is compulsory basically. We will get v, that is 6 minus 7x, into du upon dx, that is 0, u, that is 5, into dv upon dx, that is negative 7, and divide by v, that is 6 minus 7x the whole square. Mug up the formulas if you don't remember them, but remember the working rules is a must. So now in the next step we will put this value in place of this here. So it will be 3 plus 4 2s are 8x plus 6 minus 7x into 0 minus 5 into negative 7 divided by 6 minus 7x whole square. So next step will be 3 plus 8x plus 6 minus 7x into 0 is 0, and negative negative makes it positive, and 3 5s are 5 7s are 35. Division will be as it is. So in the last step, 3 plus 8x plus 35 divided by 6 minus 7x the whole square. This will be your final answer. So this kind of questions could be asked. You have to solve those separate working rules separately and then put them into our regular question. Question number 18, illustration 18. Now this might seem like a division and multiplication combination, but actually the first bracket which we have here, when we solve it we will know that this is something else. First of all, let us write down the question as it is, and then what we are going to do, we are going to take an LCM of x plus 5 multiplied with x. So x into x plus 5 plus 6 divided by x plus 5 the common, and then 3x plus 2 divided by x square plus 5x plus 6. When you multiply now x square and 5x, you get something like this: x square plus 5x plus 6, and then here again you have x square plus 5x plus 6. So you are going to cancel these two values, and in the last step you will get 3x plus 2 upon x plus 5. That means you don't need to multiply these equations, you directly get a division rule. What we are going to do, we are going to apply 3x plus 2 as u and then x plus 5 as v. So when we get du upon dx, 3x becomes just 3, 2 is 0, and dv upon dx, x becomes just 1 and 5 is 0, so it is just 1. And we will write down the formula here, because this is a dedicated division rule question, so I am giving you the formula, but not necessary each and every time you will get the formula here. Okay, you have to remember it. V into du upon dx minus u into dv upon dx divided by the v square. So what we are going to do is we are going to put the values. V is x plus 5 and du upon dx is 3, u is 3x plus 2, dv upon dx is 1, and then v, that is x plus 5 the whole square. We will multiply these brackets, 3 into x plus 5 and 1 we multiply or don't multiply, doesn't matter. So 3x plus 15 minus 3x plus 2, it will be as it is. We will open the brackets, 3x plus 15 minus 3x minus 2. As you know, division will be as it is. 3x this and this negative 3x will be cancelled, and 15 minus 2 is 13. So the final answer is 13 upon x plus 5 the whole square. We will move forward with the next illustration. That is illustration 19. Fx is equal to 3x square plus 2x plus 1, then find f dash x. Now let me remind you guys once again that f dash x is just another method of saying that we have to use the differentiation method. Whether we write down dy upon dx or we write down f dash x, it does not matter. But then there is one additional thing, that we have to obtain f dash 1. So first of all we will find out the differentiation, and then we will put this 1 into the given answer which we have just found, and then get the second answer. First of all I will write down the equation, that is fx is equal to 3x square plus 2x plus 1. Next I have to find f dash x. Now we have been well versed with this, so we will directly do it. X square is 2x, 2 comes into multiplication, and 2 minus 1 is just 1. 2x where x is directly 1. You must remember these things now. And in the next step we will simplify it finally. 3 2s are 6x plus just 2 because last one is 0. Now we have to find f dash 1. That means in the place of x I will be putting 1. So it will be 6 plus 2. The final answer is f dash 1 is 8. So the answer for this particular illustration is f dash 1 is equal to 8. So these kind of questions are basically very easy to solve. These kind of questions can be asked for 1 or 2 marks in your board exams. Let us take a last sum and then end this tutorial. We have to find fx is equal to x square minus x plus 3. Now this is fx given, and we have to find the value of x for which f dash x is 0. Okay, now before we think about what is asked, let us just say that f dash x is to be found first. So fx is x square minus x plus 3. So when we differentiate it, x square becomes 2x, x remains 1, and 3 becomes 0. So 2x minus 1 is the question. Now we have to think about f dash x is equal to 0. So we will take f dash x is equal to 0. Now f dash x is 2x minus 1. So we will put 2x minus 1 is equal to 0. Okay, so what we have to do, 2x minus 1 is equal to assumed as 0 because question is asked such. We will change the side of negative 1, it will be 2x is equal to 1, and then we will change the side of 2, so we will get x is equal to 1 upon 2. That means that when x is 1 upon 2, the f dash x will become 0. Okay, so that was the question, that for which value of x. So the value of x is 1 upon 2, for which f dash x will be 0. Okay my dear friends, so with this I end some of the illustrations depending on the working rules of the chapter. In the next tutorial we will be discussing some other topics of this chapter. This chapter is quite wide, which includes many topics, so we will discuss those topics in the next tutorial. Till then, stay tuned and see you soon.